In this video I'm going to talk about tangent to a circle and that it is perpendicular to the radius at the tangency point. So basically let's draw a picture. So we have a circle and we have a tangent, something like this. Yeah, so this would be the tangency point, and let's say O is the center of the circle. Then this radius OT is perpendicular to the tangent line. So let's denote the line by T, and the statement says that, so the theorem says that OT, the radius at the tangency point, is perpendicular to the line T, to the tangent. So so let's prove the theorem. So I will draw another picture for it to like deliberately seem not to be a right angle. So let's say that we have this so let's say like this. So we have tangent. So what we will do is, so if it's not a right angle, then we will draw a perpendicular from the point O to this line T. So it should be somewhere, like, because we always can construct a perpendicular, right? So let's say this point is T prime. So the base of the perpendicular. So then we see that the triangle OT T prime, like it is a right angle triangle, right? It is a right angle triangle, and we know that in a right angle triangle the longest side is the hypotenuse, so the side that is opposite to the right angle. So OT prime, so from this it follows that OT prime is the longest side, not OT prime, OT, because the right angle is T prime is the right angle, so OT is the longest side. The longest side in this triangle, OT T prime, right? So but on that, so in particular, we can rewrite this follows that like OT is greater, strictly greater than OT prime. But on the other hand, by the definition of tangent, a tangent is a line that has only a single point in common with the circle. So a tangent so a tangent so T has a single point on the circle, and all other points of this line T, all other points of T of the line T lie outside of the circle. Right, this is by definition of the tangent. So a tangent is a line that has only a single point in common with the circle, and all other points obviously lie outside of the circle. But then, like, we know that the circle is the locus of points that has the same distance from the center, which is the radius. So, but all points inside the circle have a distance less than the radius, and all points outside of the circle have distance strictly greater than the radius from the center. So from this we conclude that, so in particular the point T prime, if it's different from T, so like we assume that T prime is not equal to T, it's not the same point, because if it's the same point, then the statement is proven. That's what we need. So the point T prime then lies outside of the circle. If you denote the circle by omega, let's say just for convenience, outside of omega. Outside of omega. Yeah, and here we can also replace lie outside of omega. So but if T prime lies outside of omega, then the distance to the center must be greater than the radius. So OT prime must be strictly greater than OT. OT is the radius. So basically we look here, and this is a contradiction. Yeah, contradiction that concludes the proof.